Hello everyone. Today we have gathered here to discuss the quick solutions of the physics portion of the test 1 from the All India Caste Test Series Medical 2020. This test was conducted on 28th of July 2019. So let us proceed to the first question of the test. Dear students, the first question says that a point charge of 100 microcoulomb is situated at origin. The magnitude of electric field at a location having position vector 3i cap plus 4j cap meter is. Dear students, we know that electric field due to a point charge can be written to be equal to kq divided by r square, where k is the Coulombic constant, q is the charge, and r is the distance from the charge where the electric field is to be calculated. Here r is being given in the form of a vector, so we can find the magnitude of this vector to be equal to under root of 3 square plus 4 square, that will be equal to 5. Now substituting the given values in this formula, we can see that electric field will be equal to 9 into 10 raised to power 9, that is the value of k, multiplied by the value of charge which is given to be equal to 100 microcoulomb, that will be 100 multiplied by 10 raised to power minus 6 divided by r square, and r we have calculated to be equal to 5, so 5 square. Dear students, on solving this fraction we get a value of 36,000 Newton per coulomb or 36 kilo Newton per coulomb. So therefore the correct answer for this particular question should be option number 1. Now let us proceed to the next question, which is question number 2. Dear students, question number 2 says that an uncharged conductor of arbitrary non-spherical shape has a spherical cavity with a point charge q kept at its center. The induced surface charge densities at the outer surface of conductor and inner surface of cavity in electrostatic condition are respectively. So dear students, as per the question, we have been given a conductor of an arbitrary non-spherical shape, and inside this conductor there is a cavity which is spherical in shape. As per the question, inside the cavity there is a charge of magnitude q which is kept at the center of the cavity. Now dear students, we know from the properties of the conductors in electrostatics that in the inner surface of the cavity, because charge q is kept at the center, the surface charge density which will be induced will be uniform. Now dear students, since the outer surface of the conductor is non-spherical, which means that the radius of curvature of the outer surface of the conductor is different at different points, therefore the surface charge density will be different at different points on the outer surface of the conductor. Therefore the surface charge density on the outer surface will be non-uniform. Now dear students, therefore the correct answer for this particular question should be option number 3. Now let us proceed to the next question, which is question number 3. Dear students, question number 3 involves a circuit of resistances and capacitor. The question says that the charge on the capacitor at the instant as shown in the figure is. A simple circuit diagram has been given to us wherein currents at different branches in the circuit are shown, whereas in certain branches such as this branch and this branch the current is unknown. Now dear students, using the simple calculations of the Kirchhoff's current law, we can find out the current in this branch as well as the current in this branch. Since a 10 ampere current is flowing inwards towards this junction and a 4 ampere current is exiting away from the junction, the remaining current, that will be equal to 10 minus 4, which will be equal to 6 ampere, this much amount of current would be flowing into the arm. Now dear students, since 6 ampere current is flowing towards this junction and a 2 ampere current is exiting away, the remaining current, that will be equal to 6 amperes minus 2 amperes, that is 4 amperes. So this much amount of current will be flowing in this arm. Now dear students, let us represent this point as point A and this point as point B. As per the question, since point B is grounded, therefore the potential of point B should be equal to 0. Now applying an equation of Kirchhoff's voltage law from point A to point B, we can write that the potential at A, which is equal to 100, plus the potential drop across the 2 ohm resistance, which will be equal to minus of current, that is 10 multiplied by 2. Dear students, we are using a minus sign because we are moving in the direction of the current. Now as we write further, we can write the potential drop across the 4 ohm resistance, which will be minus 6 into 4. Now let us assume that the potential drop across the capacitor is equal to Vc. We introduce a term of Vc in this equation. As we move further, the potential change or the potential drop across the 6 ohm resistance can be written to be equal to minus 4 into 6. Now this should be equal to the potential of B, which is equal to 0. Dear students, solving this equation, we can get that Vc turns out to be equal to 32 volts. Now we know that the charge on a capacitor is equal to the capacitance multiplied by the potential on that capacitor. Introducing or substituting the values, we know that the capacitor's value has been given to be equal to 2 microfarad and the voltage is equal to 32 volts. Therefore the charge will be equal to 64 microcoulomb. So therefore dear students, the correct answer for this particular question should be option number 3. Now dear students, let us proceed to the next question, and the next question is question number 4. Dear students, question number 4 involves a circuit of capacitors, and the question says that equivalent capacitance of the circuit shown in the figure between points A and B is. Now dear students, if we analyze this circuit, we can see that these 3 capacitors in totality are short circuited because they lie across the same conducting wire. Similarly, this capacitor is also short circuited because this also lies across the same conducting wire. We can draw a simplified circuit diagram for this question, which would look like this. This is terminal A, this is terminal B, and there will be a total of 1, 2, 3 and 4 capacitors. The capacitance of each capacitor is given to be equal to C. Now dear students, we can see that these 2 capacitors are in parallel. Therefore the net capacitance of these 2 capacitors will be equal to C plus C, that will be equal to 2C. Now dear students, we can see that this 2C capacitance, this C capacitance and this C capacitance all are in series. Therefore the net capacitance can be written to be equal to 1 by C plus 1 by C plus 1 by 2C. Solving this equation, we can get that C net to be equal to 2C by 5. Therefore dear students, the correct answer for this particular question should be option number 1. Now dear students, let us proceed to the next question, which is question number 5. Dear students, in question number 5, an electrical network is given and the question says that the value of current I in the electrical network as shown in the figure is. So as we see this particular electrical network, we can see that certain currents are exiting while certain currents are entering this network. Dear students, we know from the concepts of Kirchhoff's current law that in any electrical network, net incoming current should be equal to net exiting current. Now dear students, in this particular diagram or the network of currents, we can see that 10 ampere current, I and 3 ampere currents are the currents which are incoming. So the net incoming current can be written to be equal to 10 plus I plus 3. This should be equal to net exiting currents. The exiting currents can be circled: 1 ampere current, 2 ampere current, 1 ampere current and 11 ampere currents. So therefore we can write the net exiting current to be equal to 1 plus 2 plus 11 plus 1. Now dear students, on solving this equation we can see that I comes out to be equal to 2 amperes. Therefore the correct answer for this particular question should be option number 1. Now dear students, let us proceed to the next question.